Chapter 10, Artificial Intelligence. This is the final chapter, and then we conclude this book. So far we've learned several machine learning techniques all the way till 9 chapters. And we must be wondering, what is AI? What is artificial intelligence? So this chapter will help us really get the big picture of how we use machine learning. We'll go into some aspects of general purpose machine learning, deep learning, stochastic gradient descent, and end with reinforcement learning and the current state of AI. If I were to summarize this entire chapter in one line, AI systems, they learn on their own using machine learning predictors to help automate and accelerate human tasks. There's lots of things packed into this one line, but in essence, businesses and people can use machine learning techniques to automate and accelerate tasks that a machine can do. Example, let's take an example. Self-driving car. When we are driving, we are not doing something productive. What if a machine can drive a car for us? When we're trying to find an information and easily try to understand something, what if a machine can do all of that heavy lifting, read from 15 different sources and summarize something for us in ChatGPT, right? So these are examples where machine can do a much better job for us and make us more productive. That's the role of AI. AI is a system that is a tool that machines can empower human beings to do a lot of tasks in a much better way. So what's the relationship between AI and machine learning? So far in the 9 chapters, we have learned about machine learning, but the way you combine these two is, think about this as AI combines several machine learning algorithms to solve a complex task. Because a single machine learning algorithm does a specific task which is very straightforward, and it either predicts or gives you some inference around like what are the causes, what are the factors that impact a certain prediction. But if you want to do a complex task like driving a car or understanding various documents, synthesizing it like ChatGPT, it requires several machine learning algorithms, maybe hundreds of machine learning algorithms, and combine it into a coherent task or coherent high-level activity. So the main role that this chapter ends with is it'll help us understand like what does it take to build an AI system. We have built so many algorithms so far in machine learning, but like what are the requirements of building an AI system, and what changes can we anticipate that's coming our way in the future because of AI. So to understand this as to what are the building blocks of AI, how do we build an AI system, there are 3 aspects that we need to build to an AI system. First, we need a data strategy where we have lots of data that our machines can learn from. Then we'll have machine learning algorithms that use this data. And then we will have an AI system that combines and orchestrates various machine learning algorithms for a higher level task of a business. So to have an AI system, you need a data strategy with lots of data assets. You need an ML algorithms, be able to build those algorithms that we've learned over the last 9 chapters, combine them for a higher level business task. What is a data strategy and what are data assets, right? Why do we need data? Remember, machines are just learning from what humans are doing. In this case of driving, self-driving car, the machine figured out what is the best way to drive based on human input, human data. So data is the starting point. You need lots of data of your customers' interactions, customer patterns, buying behaviors, churning behaviors, and all kinds of actions that you'd have to start tracking if you want to have a system that predicts what will happen. And you need a system and a strategy where you keep getting new and fresh data, because if your data becomes old, your machine learning systems will slowly atrophy and not really be useful, right? So various data tracking mechanisms are needed via various sensors, various mechanisms for parsing text, video, images, all kinds of data have to be generated from your customers. And then you can build machine learning algorithms on top of which with deep neural networks which can understand various types of unstructured data, text, audio, video, and then use various techniques for machine learning model tuning that we've seen, um, out of sample error reduction, stochastic gradient descent, and GPUs, right? Various GPUs you'd have to use for compute, high compute. So you need various tool set of the second layer of machine learning. And finally, then you need an ability to break down business problems to orchestrate various machine learning algorithms to work together. So once you have that business expertise to define like what are the economic goals that you want to set, what measures of success you want to set for your AI system to achieve, then you can have an AI system built. So that's what you need to build an AI system. I gave you an example of, let's take two examples. One was the self-driving car. So for us to build a self-driving AI system, you need lots of data where the machine's just observing real drivers driving. And so these systems will have sensors, video sensors, and hundreds of machine learning algorithms, one algorithm just to learn how to react when the red light becomes a green light, or a green light becomes yellow light and yellow becomes red. Learn how to detect pedestrian crossing even when there's a green light. There'll be like hundreds of such scenarios, and you'll build lots of data scenarios that you'll have to feed your machine learning algorithms and build several algorithms that specialize for a key task, and then have an AI system that understands, given all of those output from various algorithms, what to do. Similarly, if you're a stockbroker and you want to build an automated AI system that trades stocks, you would need lots of data, historical data that says, hey, this is a good trade, this is a bad trade, good and bad in terms of optimizing for profits, and based on various news, how to act, when to act, what not to do. Lots of historical transaction data is needed. Then you'll build machine learning models that process text like news information, process like events of like who's placing what kind of orders, looks another machine learning model that looks at option data, futures data. So you need lots of such signals, and then you need an AI system that says, hey, I'm gonna get all these machine learning models to work together in a constraint that says, hey, don't have losses beyond certain points, do not trade in certain way, or close all of your orders in certain time frame. So you need a lot of those systems. So those are two examples that I walked you through. One is self-driving car AI system that does that. Another is automated trading. So that's all of them require these three foundations: of data, machine learning algorithms, and an AI system that orchestrates all of that for a specific business problem. So this is another example of a shopping mart, Amazon Go, where a customer, I've been to one such store where you go in, you just pick whatever you want, and you go out. There's no one at the checkout store scanning your items. The AI systems figured out through various sensors and cameras here as to what is in your cart, and it automatically knows who you are, and then it sends you a bill. So basically, we are able to make a lot of these AI systems more general purpose, because businesses are getting more and more involved in asking not just prediction problems, whether the customer is expected to buy something given that they've entered your store, but also like what are the factors that lead them to buying something? What are the factors that causes them to buy something? So we're going away from just prediction questions to also inference questions, and we're building lots of deep neural networks which are modular. Certain layers, certain algorithms that are optimized for images can be combined with layers that are optimized for text. So you could start to imagine various types of machine learning algorithms at play here that watch the activity of the customer, that scan the activity of various products that are in your cart, and so on. And so with things becoming more modular, business is taking more interest, and data becoming more abundant, which can be processed at scale, it's becoming more and more of a commodity where some of these systems are going to be available and used in various use cases. Like we talked about several, like self-driving car, shopping, eventually also like not having to Google 50 times. You'll just ask ChatGPT to do a lot of that work for you, conversational agents and stuff like that. So it's becoming more and more mainstream where a lot of these tasks are going to be automated. Does that mean that a lot of jobs are going to be gone? I would say some types of jobs would be gone, but many more types of new jobs have been created and will be created like in the past. We've seen several technology revolution with digitization, computers, mobile phone, new types of jobs are being created, many more than the ones that are being displaced. So this is a good thing. Let's get started, use this as a tool set, and keep improving and learning and making our life more productive. So various points in the history where we have slowly been talking more and more about ChatGPT as of last year, but it was all started about in around 1958 where they started to say, hey, human brain is intelligent. How can we model structures around mimicking the brain? And then pattern recognition, then deep/modular neural networks became more and more available. Image classification surpassed human abilities, and now conversational AI with ChatGPT, who can understand language and converse with you in language form in depth that you need. So this is just the beginning. We've just barely scratched the surface of various topics in AI. There's this really good conference that happens every year, which has a lot more topics to check out. And one technique in which the neural network or learns, or the AI system learns, is through gradient descent, stochastic gradient descent. So I asked ChatGPT, we've been talking about this example as to, hey, in machine learning, why do we need to minimize cost function, right? And gradient descent helps us minimize a cost function. So a cost function in a sense is basically the difference between the predicted value and the actual value, right? And look what ChatGPT says. In machine learning, we use cost functions to measure the difference between predicted value and actual value, right? So you're making an algorithm predict whether given customer coming into your Amazon Go shopping mall, will they buy something? And so you want to minimize the cost between your prediction and actual reality. And so that's why you minimize cost or the loss of function as to what will happen and what actually happens, your prediction and reality. And so that's why we need to be able to minimize cost. And neural networks are trained using this technique of back propagation to accurately entrain through various gradient descents. So every node of your neural network will know how to minimize this loss function. And you can imagine there'll be so many data points and so many nodes in your neural network. So that's where we have this stochastic gradient descent, because it doesn't require all of those sample of data sets, all of the data in your available data set to go through. You just go through a subset of such data. And this image from this YouTube video, it shows that, hey, this finds the minima, but stochastic gradient descent, because of this error, actually can find better minima and not just stop here, right? Because it's going to add a subset and of those samples, which adds some sort of noise, but also captures the minima much faster with a smaller set. So that's a technique to learn. And similarly, another technique is reinforcement learning, where you teach an AI system based on reward system, saying, hey, if I want you to learn how to walk, then there's various combinations that this machine, this AI system will know how to go to this green box. And it does it by these three steps: event, response, and reward. So the event is the AI system falls on the ground and we expect it to walk here. The response is it tries various things, and then it gets a reward based on how good it tried. So it keeps doing various event responses, and then finds out, okay, which reward's working for me. Eventually it learns out how to walk. It's similar to a child. When a child gets an encouragement after doing something good, they do it more. So it's basically accumulating data like a small child who's trying to learn to walk, and it's trying to learn what parameters to use. How do we get to convergence towards an optimal reward and get the maximum reward and minimize the regret of not getting the maximum reward. So this is the final slide. AI is becoming more general purpose, as I told you, with various cloud computing services providing this as a prepackaged models that people can use. Um, the advent of using statistics, machine learning, and computer science with big data has led to this creation of this book called Business Data Science, right? And it has helped us really increase productivity because there are lots of functions like self-driving car, ChatGPT, and others greatly increases productivity. And we learned in economics there are three things that impact output or production: productivity, capital, and labor. Productivity is a big factor. So AI helps us improve productivity. But if we now combine that with applying that to a specific big business problem and be able to orchestrate AI systems for a specific use case, that's when business becomes business AI and not just business data science. It's combined business data science with economics or applying it to your business domain. That's where the real game is. That's where a lot of people are going to get a lot of new jobs to be able to use and build these AI systems. So this was amazing. We've gone through quite a bit and finished this book together. Thanks for staying with me. Put in comments what you like the most. And there's also a blog that I have written. Go to deepandbrief.com and you will see this index page, business data science, and I'm starting to create for every topic that we've covered, for every chapter. All of this is going to be there on deepandbrief.com. Yeah, so check it out and stay in the loop. I will be also sharing few more videos. I'm not yet done. I know the book is done, but related to business data science, because a lot of new things have come out after this book was published, and that's not covered in this book. So I'm going to add some extra videos at the end of this. So thank you all, and happy learning.